Hello, hello everyone. Welcome back to the channel. Today we will be taking a look at these two questions from the what you can say CodeChef starters round, CodeChef starters 169th round. So we will solve this third and the fourth question. Okay. So yes, let's go forward. Okay, the third question is Hamming equivalent. Okay, so there are timestamps in the descriptions for those of you who want to skip the problem intro, and yes, for those of who you want to listen to it, here we go. So you are given a permutation P of length n. Okay, so you are allowed to perform the following operation any number of times. So we can choose any two numbers pi and pj such that the number of set bits means ones in their binary representation is the same, and we can swap them from their positions. So determine if it is possible to sort the permutation in the ascending order using this operation. If possible, print yes, otherwise no. So I think problem statement is self-explanatory. So what this problem statement is saying is that, so let me give a brief overview of the problem statement. So you will be given permutation from 1 to n. Okay, so permutation is basically the first n natural numbers. Okay, and yes, arranged in any order. So suppose you are given this permutation 1 3 4 5 2 6, or you can say 8 7. So let us take this 8 and put it in the first index of our permutation. So binary representation of 8 is 1 0 0 0. Binary representation of 3 is 1 1. That of 4 is 1 0 0. That of 1 is 1. That of 2 is 1 0. That of 1 is 1. And of 7 it is 1 1 1. Okay. So what I can notice is that, so here in the binary representation of 8, binary representation of 4, 2 and 1, there's one set bit, right? Makes sense? I think completely does. So we can swap their positions, right? So we can swap them interchangeably, 8 or 4, 4 or 2, 2 or 1, or what you can say 4 or 1, 8 or 2, 8 or 1. We can swap any of these two any number of times we want. Okay, so that is basically what the problem is saying, and our goal is to sort this permutation. So by performing the operations, we want to make this permutation as this thing. Now consider the case here. So here my 2 can go to the position here, so which is basically 7th, this is 5th, this is 3rd, and this is 1st, but the original place of 2 is here, right, at the second index. At the second index there should be 2. So answer for this sample input or the input is going to be nope. We cannot sort the given elements by performing the described operation. Makes sense? Okay, yes, it completely does. So what we will try to do is that, okay, so we can easily devise n log n solution. Okay, so let me take this thing. Okay. Oh, this thing. right here. Okay, so what I will do is that, for suppose I will store the number of set bits. I will store number of set bits and its corresponding numbers. Corresponding numbers and their indices in the given permutation, and their indices, okay, in the given permutation. So here our case would be something like, so for set bit 1, for one set bits we have 8 and its index is 1. We have 4, its index is 3. We have 2, its index is 5. We have 1 and its index is 7. So can I argue that after sorting these vectors, after sorting this and this vector, after sorting this and this vector, if they both are equal, if they are both equal for all the number of set bits, for 1, for 2, for 3, so these are basically number of set bits, okay, so not till 3, so on up to, for whatever number of set bits are possible, if these two vectors for every number of set bits after sorted, if they are equal, so basically what I'm trying to say is that, so suppose if 8 was on the position 4, okay, so 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 let me draw it here. So what does that mean? So for suppose for the values 8, 4, 2, 1, for which number of set bits is equal to 1. So suppose 8 was at index 2, 4 was at index 1, 2 was at index 8, and 1 was at index 4. So if I sort these both of the vectors, if I sort both of these vectors, so they will basically become 1, 2, 4, 8 and 1, 2, 4, 8. So basically they both will become exact same. So if it happens for all the number of set bits that are possible in the given permutation, then my answer will be yes. Makes sense? And otherwise, if it will then or otherwise it will be no. So crux of the logic lies in the fact that I can interchange this 8 with 2 or whatever it is. So I can rearrange this indices for these given elements, right? For these elements. So it is becoming little cluttery. So for these given elements, I can arrange the given indices. I can arrange the given indices in whatever manner I like. That's why we are going to approach solving this question by storing the number of set bits, and according to it storing the corresponding numbers and their indices, and we will sort these number vector. We will sort the number vector, which is basically this. We will sort this number vector, then we'll sort the indices vector, then we'll sort the indices vector, which is basically this vector, and if they both become same for every number of set bits, then we are good to go. We can sort our given permutation. Yes, that's basically the solution. So let us take a look at the code. So I hope the code is visible. If not, we will make it big. Yes, so taking the input till here, and yes, so we will make a map of long for this thing. So for first argument of this map, ll will store the number of set bits, and this vector of pair comma ll will store the values and its corresponding indices. So yes, we iterate over the every element of the array. And what this built-in pop count function does is that it is built-in function as its name suggests. So it will return the number of set bits in the binary notation of its argument. So it will give the number of set bits in this v of I. So in that so in m of that number of set bits, we will push back. So this will basically be the vector, and we will push back the value and its index. Okay, so we will initialize one bool called true. And so yes, for every entry in m, so for every entry in m, basically for the every value of set bits possible, we will copy the entries in vector a and vector b. So vector a will contain every value, and vector b will contain their respective indices, and we will sort both the a and b vectors. Okay, and compare every value from that vector, and compare every value from that vector, and even if one of the values is different from the other value, so one of the value from a vector is different at the okay wait so even if one of the value is different in vector A to compared to the vector B, then possibility of making the permutation sorted is 0. This bool will become false. Okay, and yes, we will directly break from here, and if it is not possible, then we don't need to check the further entries in the M, and we will break. So finally, if it is possible to make the permutation sorted, we will output yes, and if it is not, we will simply output no. And yes, and it passes the system tests, or whatever it is called, hidden test cases, very nicely. And yes, that's basically the solution for the third problem. So we are done with the third problem. Okay, nobody has still solved the fifth problem. Okay, sixth problem, sorry. Okay, anyways, let's focus on the solution of the fourth problem. Okay, so yes, so fourth problem. Again, there are timestamps in the description. You can directly skip to the solution if you have grasped the problem statement very well, and if not, hang with me. So make k most frequent. So you are given an array a of n integers. You can perform the following operation any number of times. Select and remove any prefix or suffix of the array, but not the entire array. And our goal is to determine the minimum number of operations required to make k the most frequent element in the array A, and it is guaranteed that k is initially present in the A. Okay, so this is the key point in the problem statement. Okay, so the first line of the input will basically be the t, number of test cases. Then there will be n, basically number of the elements and the initial array A, and there will be our k. Okay, k, which the element which we have to make the maximum of in the array. So and ai, so ai are basically the elements of the array. And notice very important fact here is that both k and ai are both up to 20. Starting from 1, they are going till 20. Okay, this is gonna help massively in our solution. Okay, so it is guaranteed that k is present in the array. Okay, and sum of n over all the test cases does not exceed 2 into 10 to the power of 5. Okay, so one more thing here. Okay, so let us clear here. So second problem. Second, actually, let's be consistent with the numbers. Fourth problem. Fourth problem from the CodeChef starters 169. And yes, so in this question, suppose 1, 2, 3 and 4. Suppose this is one array and n is equal to 4. We can say that 1 is most frequent, 2 is also most frequent, 3 is also most frequent, and 4 is also most frequent. So basically, most frequent here means there's no element in the array, there's no other element in the array, whose frequency is bigger than our element. Makes sense? Yes, it definitely does. Okay, so I should have not wrote this. I should have told it verbally. Okay, but anyways, so n is equal to 4. Okay, let us take a look at the sample test cases itself. Okay, so yes, I think they are self-explanatory still. So let us take a look. So in the first test case, number of operations needed is just basically 0 because 1 is the only element and it's most frequent. In the second test case also, if we want to make 2 most frequent, number of operations needed is 0 because 2 is already most frequent in the array. For the third test case as well, it is basically same as the second test case, but just k is changed, nothing more. Here answer will also be 0. For the fourth test case, you have to make this one most frequent, right? So for this you can make one operation on this prefix 2 comma 2, and then you'll be good because your array will finally become 1 comma 2, and 1 is most frequent in this array. So number of operations here is 1. What about the fifth test case? So for this kind of test case, so you have to do 2 operations, first on this prefix and second on this prefix. So afterwards you'll be left just only with 3, and number of operations you have performed is 2. So based upon the top observation, my answer is upper bounded by 2. Make sense? Yes, it definitely does, because suppose here is the prefix of the array, here is the element, let us call it elem. Here is your element. Okay, this is basically only one element, and here are the other positions of the array. So if you want to make this element most frequent, you will just perform one operation on this prefix, right, and you will vanish it. Okay, then it will be somewhat like this, and then for the second operation you will select this suffix and you'll vanish it, and yes, you are done by making this element the most frequent element in our array. Yes, so answer is basically upper bounded by 2. So my answer can be 0, 1 or 2. So when will it be 0? So this is basically trivial case, right? So in from initial before any operations, your count of the k is basically at least as bigger as any of the count of the other element, right? So this is trivial case. So what about 1? Okay, so one thing we can notice here is that So if my answer is not 1, so if my answer is not 1, it will definitely be 2, right? So if I am able to figure that so it is trivial for 0, and if I'm able to figure that my answer is 1 or not, so basically my solution will be done, isn't it? Yes, it definitely will be done. Okay, so let's figure out if it is possible to make our answer 1. So is it possible to make the k most frequent element by performing only one operation? Okay, so let us take a look at this test case. Okay, not that test case. Let us consider, okay, some powerful test case. Okay, so one more thing, I told you that the constraints are of really importance to us here. Okay, so if your answer is 1, so basically either suppose there is the case when you are removing a prefix, and then there's a case when you are removing the suffix. Okay, then there's a case when you are removing suffix. Okay, so if you are trying to remove prefix, okay, so suppose you remove prefix of length L, okay, and here so so if you try to remove prefix of length L, then the first element after removing this prefix should be K. Makes sense? Makes sense? Yes, it definitely does. Because if it is not k, suppose if it is not k, so you are removing length L, and here something element, some number is there which is not k, then basically just extend this L, right? You are not worsening your answer, rather you are, what you can say, making it better, right? So what if how are you making it better? So what if this element was the most frequent in our array, but after performing this operation it becomes the less frequent than our k, right? So basically it betters our answer, right? So that is basically the thing, and that's why another key observation is that whenever you remove a prefix, whenever you remove a prefix, your next element should be k. Okay, makes sense? Yes, it absolutely does. And what I will do is that I will make the count array of length 21. Why 21? To avoid the zero based indexing, and I will store count of 1 will be frequency of 1, count of 2 will be frequency of 2, so on up to frequency of 20, right? So on up to count of 20, because AI is upper bounded by 20. Makes sense? Yes, it definitely does. Yes, it definitely does. Okay, so we will try iterating for so basically if I tell you how to proceed for the prefix, you know how to proceed for the suffix as well, right? So let us take only prefix into the consideration. So you will start your journey from 1 to n, and whenever you encounter k, remove prefix before that element, before that k, and check check if k is most frequent element, and we will do it for every index. We will do it for every index where our input of index, where our input of index is basically k. Okay, we will do it for every index where input of index is k. Okay, and we will try to figure out if this k is becoming most frequent or not. So if it is becoming most frequent, then our answer is 1. Okay, so we will try to check it for prefix and for suffix as well. And if in these both cases we fail, so suppose in this both cases we fail, then our answer is definitely going to be 2. Make sense? Yes, it definitely does. And what will be the time complexity of this solution? Will it fit the constraint? So time complexity, it would be O of 20 into n, because our AIs are upper bounded by 20. So you want to check, so you want to check only the frequencies of the numbers from 1 to 20. Makes sense? Yes, it definitely does. So if you end up checking it for every index, so that won't be happening. So anyways, if you still end up in the worst case, suppose for the index or index by 2, whatever it is, the order of n indices. So if you end up checking for those, still your time complexity would be O of n, right? So that constant 20 doesn't really matter. So it will basically be the order of n. So makes sense? I think it definitely does. So let us head towards the code to understand it better. So I hope code is visible. Yes, it definitely is. So yes, taking the input, initializing this count vector, and yes, so checking if answer can be 0 or not. Okay, so checking if the answer can be 0 or not. If it is 0, then we will find simply output the 0. So basically, if our max element, if it remains to be k, if it happens to remain k, then our answer is basically 0. Okay, now comes the most important part of the solution. So else we will check if the answer is possible to become 1 or not. Okay, so we will initialize it with false. Okay, possibility with the 0, and yes, we start. So here for this part I am considering the, what you can say, prefix case, and for the further count here for the further solution I am considering this part for the suffix. Okay, makes sense? Yes. So if v of I is not k, you just erase one count of frequency from that count array, right? So and if it is k, then yes, you again make a check. If it is possible to make max element as k, and if it is possible, we will render this possible bool as true, and we will break that for loop. Yep, makes sense. And don't forget to decrement the count of k. Don't forget to decrement the count of k if max element is still not equal to k. Why so? Because after processing this where is it, so after processing this k, if if it is not possible to make answer as 1, so to check for this further index, we have to decrement the count of k, right? Makes sense? Yes, it definitely does. And yep, So maximum of element is, if it is equal to k, then it is possible to make answer as 1. Okay. And one more tricky thing here is that don't forget to reinitialize this count array. Don't forget to reinitialize this count array for the suffix calculations. So because in this prefix calculations, this count array would have been modified, right? Definitely it is modified. So it is absolutely necessary to reinitialize the count array. Yep. And similar thing we are doing for the suffix. In this case, we have just reversed the order of our iteration. And if it is possible to make answer 1, or if it is possible to make answer 1 by just operating on the prefix or just operating on the suffix, then our answer is 1, or otherwise it is happily 2, as it is upper bounded by 2. Yep, makes sense. Yes, it definitely does. Yes, it definitely does. So that is for this video. I hope you enjoyed solving the contest and listening to the solution as well. Happy coding. Thank you for watching the video. Consider liking if you have collected something important from this video, collected some important trick or whatever it is. If you found this video useful, be sure to like it, be sure to subscribe, be sure to stay tuned with the channel. Thank you again for the watching. Yes, see you again.